Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor and Head Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about circular singly lingual list. In previous lectures, we discussed about what is lingual list, advantage and disadvantage of the lingual list, comparison between array and lingual list, and how to create the node in lingual list, and what is singly lingual list, what are the operations in singly lingual list. Those topics are we are discussed in the previous lectures. In this particular video lecture, we are going to discuss about circular singly lingual list, how we will convert circular singly lingual list into circular singly lingual list. So this is classroom topic 25, week 9, first class. Okay. So CDT-25, circular singly lingual list. So after completion of this lecture, students will be able to develop a C program to create nodes in circular singly lingual list and perform traverse, search, insert and delete operations. Okay, so how to create the circular lingual list as well as how to perform these operations. Those things we will discuss in this video lecture. Circular lingual list means the last node contains a pointer to the first node of the list. So we know singly lingual list already. The singly lingual list with start pointer. The start pointer is connected to the node. Each node have two portions. One is the data portion, another one is the pointer to the next node. So like this, we have to connect. Each node connected with the next pointer. Then last node have null pointer. So this is singly lingual list. We already know about it. But in circular lingual list, what we will do? The last node contains a pointer to the first node. So that means instead of null pointer, here this is the last node, no? So this last node next pointer is there, no? Instead of null pointer, we will change it to first node pointer. So that means this pointer will point into this node. Okay. So whatever the start pointer is pointing, no, that start pointer value will be assigned to last node of next portion. Clear? When once we connected this link, it will be the circular. Okay. So this is the main difference between singly lingual list and circular singly lingual list. Okay. So now we will see one by one. We can have a circular singly lingual list as well as a circular doubly lingual list. Okay, so we have the types singly lingual list, doubly lingual list. Both the singly and doubly lingual list have circular list. So while traversing a circular lingual list, we can begin at any node and traverse the list in any direction, forward or backward, until we reach the same node where we started. So in case single node, when we are discussed about singly lingual list, we know that the node traversal will be only the forward direction. So what happens if the node is connected like this? So we know that each node is connected like this. In circular lingual list, this is the first pointer, start pointer. Then, so circular lingual list, what happens? It is connected to the first node. So in case there is no reverse direction, but what we will do when we are doing this operation, in case we want to access this node, if we are traversal from first node, we are visited this node. So then we are visited this node. Okay. So in case we want to visit this node again, okay, in the first node again, what we will do? So there is reverse direction is not possible. But what will happen? Again, we will traverse up to last node. Then we can go forward to this direction. Then this node will be accessed. Okay. So this is the thing we are discussing this point. The circular linked list has no beginning and no ending. Okay, so the starting node we will give, but there is no beginning node, there is no ending node because there is no null pointer. So if we are added new nodes, that will be pointing to wherever the start pointer is pointing. From there, we can start the traversal. So see here this diagram. So we are have get head node or start pointer. So the pointer is pointing to the first node. Okay. So the each node have the values. This is the data part. Already you know that this is the data value. So the second portion is the pointer to the next node. Okay. So whatever address we have. So in case address 1 here, address 2 here, address 3 means here it will store A2 address of second node. Here it will store A3 address of third node. So what is this? This is last node, no? So it is pointing to the first node. So it is pointing to A1. So the head node is pointing to A1. Whatever pointing the head node, the same thing will be included in the last node of the single linked list. So once we include it, it is considered as the circular linked list. Okay. The complexity of iterations will be there. How many times we want, we can do this. There are no null values in the next part of any node because the last node have pointing to the first node. Circular linked lists are widely used in operating system for task maintenance. Okay. So if in case we are using the web pages, if we want to go forward, then we will move. So like we will click the link next, next, next. When we want to come back, we can use that reverse direction. So reverse button, if you are clicking, that next web page will comes down. No, so like that, we can use the circular linked list. Okay, so same thing, whatever I said, it is there. So how it is done? So answer is simply simple. So what we will do, circular linked list is to maintain the sequence of the web pages visited. Okay. So traversing will be start from any node, then we will move forward and reverse directions. In case of circular doubly linked list is there means we will do the reverse direction also. The last node have contained the first node of address. Okay. So in case if you want to store the data in memory, how the circular linked list will be there. So last class we discussed about the memory management for singly linked list. So now we are going to check about this hello how it is stored. HELLO. Okay, this is the word. Then each character how it is stored in the memory. So this is memory management. This is considered as address, not a serial number. This is considered the address of the each cell. Okay. So in case H is stored in the first location address, then it pointing to the next character where it is stored. So 4 it is stored, then it will comes here. The link will be established like this. Then the data is HE. The next part is stored in 7. So the link will be established to the 7 port. Okay. So then L is the character. Then it's how next pointer 8. So it will pointing to the 8. So once 8, the next pointer is pointing to the 10th location. So here 10 is connected to here. This is the linked list we are connected. So this is the last node. Normally in the single linked list, we have -1 with the last node, that is null pointer. But here, this is the circular linked list. Whatever the start pointer is pointing, that pointer we are given. So what happens after using it, this link will be established to here. Okay. So this is circular linked list. Okay. There is no ambiguity in traversing through the list because each list maintains a separate start pointer which gives the address of first node of the respective linked list. The remaining nodes are reached by looking at the values stored in the next. Okay. For example, in case two linked lists consecutively. So already we know that this is the address. The biology students, student 1, student 3, because this the next address is 3, next address is 8. So 8 have S06. and next address is 11. So 11 have S08. So the next address is 13. So next student is S10. Then next address is 15. So 15 have S11. So then the linked list will start with 2. So the next address is starting with second linked list. Got it? How it is connected? So the linked list will connect it like this: third position, 8th position, 11th position, 13th position, then 15th position. Again, it is connected to second position. So how it is linked list is connected? That will be is connected to the next link. If in case second, then it is going to SO2, then 5, then 5 is connected to SO4, then SO4 connected to 7, 7th place 05, student 5, then next place is 10, it is going to 7 S07, the next position is 12, that is student 9 is there, then it is pointing to the first location. Okay, so it is linked with first node. So to linked list, how it is connected to circularly, you know that. So in the circular linked list, how we can insert a new node in the circular linked list, that we have to think about it. So we have two options. One is node is inserted at the beginning, node inserted at the end of the circular linked list. Why? Because we connected the last node into the first node. In between, if you want to insert mean, that is similar to the singly linked list. No need to discuss here. Only the changes what we have to do if you want to insert the new node at the beginning, what we will do. If we are inserting the new node at the end, what we will do. That is we are going to discuss now. So in case beginning means what we are going to do. Suppose we want to add a new node, the list. You just see here. This is the linked list we have. The last node is connected to the first node. This is circular linked list. We will take this example. If I want to allocate the memory, so like if you want to add a new node at the beginning, so first we have to create the node. The node have data value is 9 and next part also is there. Okay. So here, after allocating the memory, we will create one pointer. That pointer will pointing to the first node. What I will write here, so ptr equal to start pointer. Okay, so initially whatever value you have in start, that will be assigned to ptr. How we will create, this is new node. Okay, so new node pointer is pointing to this new node. This is new node tends to data part. New node tends to data part equal to 9. Okay, so this portion is new node tends to next part. Okay, so we have created the new node. Initially, we one pointer we are finding it. Why? Because if I'm inserting the new node at the beginning, I want to add the new node address will be in the last node. Here I want to add it. Okay. So if I want to add it means this node I want to traverse from the start pointer to the pointer. So here what I will do, the pointer once created, it will move up to last node. So how we will find the last node? So while ptr next equal to not equal to start address. Why? Because the start address is here. It will move. Okay. Start address will be move up to start address because start address will be stored in the last node. So till that point, ptr will move to ptr next. So what we will do? ptr equal to ptr tends to next. It will move up to the last node. This pointer we are writing it. So up to it will reach the last node. Once it is reached means pointer will pointing to last node. Okay, this while loop over. Using this while loop, the pointer is pointing to the last node. Okay, so here you just see there. After inserting the pointer, we are added the new node at the beginning. Okay, so how we are added? So the new node of next equal to start pointer, new node of next equal to start pointer, and ptr of next equal to new node. Okay, so these two codes we are going to write it. Okay. So we are insert the new node at the beginning. Okay. So now we just consider after inserting the last pointer is pointing to this locations. Okay. So initially we have to check memory will be available or not. So we know that free pool will be maintained at the first available locations. So avail pointer is pointing to here. Okay. So in case if the memory location is available means it will allocate this location for one node. Okay. So this node data part and this part will be created. If memory is there, no problem. If it is not available means then it will print overloaded. Okay. So now if you are created means the avail pointer will be allocated to the new node. So now new node is created, avail pointer is availed. So then this avail pointer pointing to next free space where the free space is there. So avail pointer is pointing to avail next. So next part where the memory space available that we know it is maintaining here the next part. So the pointer will pointing to the next portion. Okay. So this is the new node. So we know that the new node of data part of this one. So whatever value we are given that will be assigned to here. And PTR equal to next start pointer. So we are creating one PTR like pointer. That pointer is equal to start pointer initially. Then the pointer will move up to start node. I told you know in the diagram same thing. So it will move up to last node. Once it is moves, the new node of next equal to start. So new node of next means this portion. Okay. So this is for already where the new node is pointing. The start pointer is pointing to first node, no? So that address we will give, so it will assign to new node, okay? So wherever the node is there, it will add before that node. So next, PTR next equal to, that last node of next portion equal to new node, okay? So this is creating the circular. And finally, start equal to new node, okay? So the start pointer we are give it to first node. This is insert operation. Okay. So end of the circular queue, what we will do? So we will create the node. Again, same memory we will check if node created. So again, we have to use the pointer to move last position. After last position, so now we are creating the node. Okay. So this node will be there. What we are going to do? Whatever pointer it is there, that will be assigned to new node of next portion. So this is new node of data portion. Okay. So what we will do, PTR tends to next equal to, or that means new node of next equal to PTR tends to next portion. Whatever it is there, that will be assigned here. So if we are assigned means this link will be established. Okay. So now what we will do, PTR of next equal to new node. So whatever the pointer is there, that will be assigned to here. So if you are assigning means the link will be established to here. The new node of data value, we will give it like this. So this is the method we are inserting it. So once we insert in the last position, we will check the memory location. If memory location over, then we will do this operation. Okay, so new node tends to data, that is the value we will assign. So next new node of next equal to start pointer. Then set PTR equal to start initially. So the start pointer will move to the, it is pointing to the new, it will move up to last node. After moving this last node, we simply end up the loop. Then PTR tends to next equal to new node. Okay, so then just we can exit it. Okay, so this is delete operation. So delete operation, what we will do? So same thing, we will delete from the beginning node, we will delete from the last node. So in case delete from the random node means that is same like this singly linked list. Only difference is beginning and the end position. Okay. So in case if you want to remove the node from the beginning. Okay. So what we will do? So beginning in case one is there. So this pointer I want to remove means what I have to do? So if theoretically how we will do, this node I want to remove. So what I will do, this start pointer will pointing to here, first condition. Then last node is pointing to this node. Okay. So if you are doing this operation, this link will be established here, and this start pointer will change, means this entire node will be removed from the list. How we will do that? For example, you see, we will first move pointer to the next node. Okay. So pointer will pointing to last node. It will move one by one. So initially we will create ptr equal to start. That is the line we are written here. This is will be happened. After start pointer, ptr will move up to last node. Okay. So ptr, then ptr equal to ptr tends to next. So this up to while ptr next equal to start pointer, not equal to start pointer, we will move. So that what we will do now, ptr will move here up to this point, it will move. So now ptr is pointing to the last node. Okay, so this diagram, ptr is pointing to the last node. So anybody have doubt in this as of now? So now the pointer is pointing to this location. Okay. So last location. Now what we will do? Start pointer pointing to the next node. Okay. So the next pointer of PTR is made to point to the second node of the list, and the memory of the first node is freed. The second node becomes the first node of the list. Okay. So we will free this memory and we will go to this node. So what we will do? Start pointer will pointing to start equal to start of next. If you are doing the, like this, means the start pointer will pointing now here. Okay, after start pointer, whatever start pointer is pointing, that will be assigned to ptr tends to next. So that is the step we will do. After doing this step, this will be happen. Okay. So algorithm, we know that start equal to null means there is no list, empty list. So otherwise, we will create one pointer that is pointing to the start node. The ptr pointer will move to last node. For that, we are using this loop statement. Using this loop statement, the ptr will pointing to the last node. Okay. So last node ptr of next means that is start of next. Why? Because it is a second node. So if you are given start means that is first node. Start of next means directly we are assigning the second node. So then free the start pointer, then automatically what happen? First node will be moved. So then start equal to ptr of next. Whatever we are assigned here, this value, that is the second node. No, so the second node will assign to start pointer. Okay, that's all. For delete at the beginning, delete at the end. What we will do? So if the linked list is there, I want to remove this list. What I want to do? So again, this link will be start from here. Okay. So just we will change this link. So what we will do, how it is doing this? So we will create one pointer here, pre pointer and pointer, two pointer we are creating. Okay, pointer will move forward direction, pre pointer is preceding of the pointer. Okay. So example, if pointer is pointing to this location means pre pointer is pointing to this location. So pointer tends to next, ptr equal to ptr next, pre ptr equal to pre ptr next. If you are doing like this, what happen? The ptr will move up to start location. So once ptr is pointing here means the pre ptr will be here. Okay. So it is moving like this. So now pre ptr pointing here, ptr is pointing here. So what we will do, I want to remove this node. Okay, so because I want to remove memory for this node, no, that's why I'm creating pointer. If only changing link means immediately we can choose ptr next equal to start. Simply we will do that. But the memory will be occupied this node that will not be freed. So for that reason we are using two pointer. The pointer is pointing to the last node, pre pointer is pointing to previous node of the pointer node. So now what we will do, pre ptr equal to pre ptr tends to next equal to what is the value? Start value. Okay. So the start pointer is pointing now, start pointer value we will give. Then ptr equal to free ptr. Free of ptr. So these two statements will make. this node will be removed and the link will be established like this. Okay. Okay. So same thing. So whatever I said, it is there, and the PTR will move. Pre-PTR equal to PTR and PTR equal to PTR next. So then it will move forward up to reaching the last node. Once it is reached, pre-PTR next equal to start, and pre-PTR will be freed. Okay, that's all. So as of now, we are discussed about insert node of first position and last position. Okay, so if you want to delete, so this is the reflections part. We have the question. So already I explained the programs. So program, if you have doubt, we will discuss in the classroom. Same algorithm we will implement in the programming. If you have doubt in the programming, you just come and ask in the classroom discussion topic. So now this is the algorithm. We written like this. Some space I given for filling it. What is the answer? I will give 10 seconds time. You try to write the answer for this. Okay. So this is the first portion. This is the second portion. So what is the answer for first and second? So PTR equal to start. If the first node is deleted, okay, so you consider this constraints. First node means what we will do. So the last pointer we will move now. So this is maybe PTR we are created. PTR will move. PTR of next portion not equal to start. Up to this portion, the while loop will be executed. So how the PTR pointer will move up to last node. So both are same answer here also. PTR equal to PTR next. Okay, this is the answer. I hope you written correct answer. So we are discussed about what is the circular linked list, how we are creating the circular linked list. We discussed about operations with examples, with the diagrams. Finally, we discussed about program like algorithms. We are discussed for all the operations. So now you are in the position to solve this question. Write a C program to create 6 nodes in linked list and make it as a circular linked list. How you can create the single linked list? After creating the single linked list, how you can make the single linked list into circular linked list? So after that, you can insert and delete a node in front and last position of the list. So after performing insert one node and delete one node, you can display the operation. So I hope you are enjoyed this video. At the end of this video, having completed this discussion on circular linked list and operation, now students should be able to develop a C program to create nodes in the circular single linked list and perform traverse, search, insert and delete operation. So students, if you have any further doubt, you just visit 6.3 circular linked list in Rima Tareja textbook. Further doubt we will discuss in the classroom discussion. Okay. Thank you for listening this video without disturbing. Thank you once again.